Hi friends, in this video, let us learn about insertion sort. So insertion sort is an efficient algorithm for sorting a small number of elements. It is similar to arranging the playing cards. So what will we do when we have a handful of playing cards? Before we start the game, we will sort all the cards so that we can make smart decisions. So we will assume the first card is in the correct position. From the second card, we will take the card and compare it with its previous card. And if it is smaller than the first card, we will rearrange the cards. Otherwise, we will simply place it in its actual position. Similarly, we will repeat the process for all the cards. So let us assume the first card 40 is in the correct position. Now take the second card, which is 10, and compare it with the previous card 40. And 10 is less than 40, so we have to rearrange the cards. Now the first two cards are sorted. Now take the third card, which is 50, and compare it with the previous card, which is 40. And 50 is greater than 40, so no need to move the cards and place it in its actual position. Now the first three cards are sorted. Now take the fourth card, which is 30, and compare it with the previous card 50. And 30 is less than 50, so move the card 50 to fourth place. Again compare 30 with the current previous card, which is 40, and 30 is lesser than 40, so move the card 40 to third position. Again compare 30 with the current previous card, which is 10, and 30 is greater than 10, so no need to move the cards and place the card 30 in the second position. Now take the fifth card, which is 20, and compare it with the previous card 50, and 20 is less than 50, so move the card 50 to fifth place. Again compare 20 with the current previous card, which is 40, and 20 is lesser than 40, so bring 40 to fourth place. Again compare 20 with the current previous card, which is 30, and 20 is lesser than 30, so bring 30 to third place. Again compare 20 with the current previous card, which is 10, and 20 is greater than 10, so no need to move the cards and place 20 at this position. And now see, we got all the cards in the sorted order. Now let us take some numbers and understand the insertion sort procedure. So let us take the numbers 40, 10, 50, 30 and 20. And as we have discussed earlier, assume the first number 40 is sorted. Now take the second number 10 and compare it with 40. And 40 is greater than 10, so move the number 40 to second place and place number 10 in the first position. So now the first two numbers are sorted. Now take the third number, which is 50, and compare it with the previous number 40. And 50 is greater than 40, so no need to change the positions. Now the first three numbers are sorted. Now take the fourth number, which is 30, and compare it with the previous number 50. And 30 is lesser than 50. So 50 should only come after 30, so place 50 in the fourth position. Now compare 30 with the current previous number, which is 40, and 30 is lesser than 40, so place 40 in the third position. Now compare 30 with the current previous number, which is 10, and 30 is greater than 10, so no moves are needed. So simply place 30 in the second position and 10 in its actual position. Now the first four numbers are sorted. Now take the fifth number, which is 20, and compare it with the previous number 50. And 20 is lesser than 50, so 50 should only come after 20, hence we have to place 50 in the fifth position. Now compare 20 with the current previous number, which is 40. And 20 is lesser than 40, so place 40 in the fourth position. Now compare 20 with the current previous number, which is 30. And 20 is less than 30, so place 30 in the third position. Now compare 20 with the current previous number, which is 10. And 20 is greater than 10, so no moves are needed and we can place 20 in the second position and 10 in its actual position. Now all five numbers are sorted. And that is how insertion sort sorts the elements. Now let us build the algorithm for insertion sort using this process. So as we discussed, in insertion sort, we always assume the first element as sorted. So we will start our process from the second index, that is index 1. So write the loop from index 1 to size. Next, we need to find the correct place and place the value one by one. So copy the current value and declare one more variable to compare and find the correct position. So let it be index and copy the current index to it. So index equal to I. And if index is greater than 0, we need to check if the previous value is greater than the current index value. And if so, we need to move the previous value to one position right. And we need to do the same process for all the previous elements. So write it in a while loop. That is, while index greater than 0 and ARR of index minus 1 greater than value. And if the condition is true, we need to copy the previous element to current index position. So write ARR of index equal to ARR of index minus 1. And in order to continue the process for all the previous elements, decrement the index by 1. And if the while execution is over, we can confirm that we have found the correct place for the value. And the variable index will have that position. So place the copied value to ARR of index. That is, ARR of index equal to value. And this is the algorithm for insertion sort, and let us understand how it will work for the element 30 here. First, let us copy the value 30 to variable value and place index in variable index to check all the previous elements. Here, index is greater than 0, so check if ARR of index minus 1 is greater than value. That is, if 50 is greater than 30, and it is. So place ARR of index minus 1 to ARR of index. So 50 will be copied to index 3. Now reduce the index value. Now again check the while condition. Now also index is greater than 0. So check if ARR of index minus 1 is greater than value. That is, if 40 is greater than 30, and it is true. So place ARR of index minus 1 to ARR of index. So 40 will be copied to index 2. Now reduce the index value. So index equal to 1 now. Now check the condition again. And index is 1 now, which is still greater than 0. So check if ARR of index minus 1 is greater than value. That is, if 10 is greater than 30, and it is not. So the loop will be terminated. Now place the value 30 in ARR of index. So 30 will be placed in index 1, which is perfect here. And that is how insertion sort algorithm works. And in the next video, we will discuss the implementation of insertion sort in detail.